In the previous video, when we were talking about simple interest rate, I kind of foreshadowed to this notion of compound interest, which is when the interest that you make each year gets like added to your account, and then when you're like making like 2% interest, you're making interest off of the interest that you were making before. That's not all that there is to compound interest, but we'll get into that shortly. There's a little bit more to it than that, but let's just jump into an example. So let's calculate the value of an investment after 3 years with an initial deposit of $1,000 and an interest rate of 5%. So I'm specifically not mentioning whether this is going to be simple or compound interest here. I'm just going to highlight I'm going to show you just like what it would be if this were simple interest, and then I'm going to show you what this would be, what the answer would be if this was compound interest. So let's do simple first. So with simple interest, we could use the formula that the value of the account after this is going to be, so we do $1,000 times 1 plus, or I guess I can just relate it to the formula first. P times 1 plus RT is going to be like the formula for us. So P is the principal, which is $1,000, and then 1 plus R is the interest rate, which is 0.05, and then T is the time period, which is 3 years. So this is 1,000 plus 1,000 times 1 plus, and this will be like 0.15. So 1.15, which is equal to 1,150. Okay, cool. So that's simple interest rate. I'm not going to explain it too much because this is like everything that we talked about in the previous video. So if this is unfamiliar to you, I recommend going back to the previous video, making sense of that first. Compound interest works as follows. So let me make a little bit more room for myself, I guess. It's in black. Okay. So we can do this in stages. So we're just going to assume that you just make 5% interest annually. So every year you just make 5% interest of what you have at the end of your year. So let's figure out like what we have after 1 year. So after 0 years, after 0 years, we start with our amount of $1,000. After 1 year, how much do we have? Well, we do $1,000 plus 5% of what we had before. So if we're adding 5%, we can think of this as multiplying by 1.05, or like 1 plus 0.05. And this is very similar to like the simple interest formula. So the simple interest formula, we do like $1,000 times 1 plus 5% times however many years we're doing it. And if it's just 3 years, then we just do it like that. Over here, this is just like 1 year, right? And then so this is equal to 1,000 times 1.05, or 1,050. Okay, well, what would it be after 2 years? Well, after 2 years, we take our previous amount, 1,050, and then again, multiply by 1.05, because multiplying by 1.05 just increases whatever this value is by 5%, right? So multiply by 1.05, that just increases whatever it is by 5%. Just repeating myself. So what is that equal to 1,050 times 1.05 is equal to 1102.5, or $1,102.50. After 3 years, we then take that amount and then multiply by 1.05 again, just, adding that 5% interest repeatedly. And what do we get? We get 157.63. $1,157.63. Okay, so this would be how much we're making. So notice that like this whole process seems like much more complicated than like what's going on here, but we will sort of develop a formula here because there is like a pattern, like we're repeatedly multiplying by 1.05. And so there is actually a little bit that we can do to simplify this whole process, which I'll tell you shortly. But what we can kind of notice here is that like in the simple interest formula, the loan value was 1150, whereas the compound interest is 1157 ish. So it's like not very different from each other. Like they're still starting like with 115. Like they only differ in like the dollar, like the ones digit, and smaller. But it is a little bit more in the compound interest, and it, this is going to like just add up over time and with like higher interest rates and stuff like that. So like these small amounts will like matter over time. All right. Do I want to? Yeah. Okay. Let's do this. So what would be a like more efficient way of like computing this value here in this example? So we started with $1,000, and then to get to a time, like time 1 in this table, we multiplied by 1.05, and then this answer, this was like 1050, right? How do we get to the next thing on the table? Well, we again multiplied by 1.05. And then how do we get to the next thing on the table? We again multiply by 1.05. So I don't really need all these parentheses here. I could just say 1,000 times 1.05 times 1.05 times 1.05. And if I'm just going to repeatedly multiply by 1.05, I could just use exponents instead. I'm just multiplying by 1.05 to the power of 3, right? And so this makes this computation a lot easier now. I'm just, all I have to do is just do just one computation, just put 1,000 times 1.05 to the third into my calculator, and like now we're getting at like a formula. I won't tell you the formula yet because like I said, there's still a little bit more that goes into that formula, but that'll show up in the next example. Hopefully this makes sense for now. So here we have a loan with a principal of $2,000 and a compound interest rate of 6%. So we don't care about simple interest anymore. We're just talking about compound now. This interest rate, 6%, is compounded monthly. And we would calculate the value of the loan after 2 years. So what does it mean to be compounded monthly? So in the previous example, we were compounding annually. So we didn't really explicitly say this ever, but it was sort of just there. What it means to be compounded monthly does not mean that you make 6% every month, okay? What it means is that you take this 6%, you divide it, like you still want this to be like basically 6% interest that you make over the course of the year. And so let me, okay, so I don't want to draw like 12 things. Let's just for the sake of explaining this, let's say that it's compounded quarterly, just for now. So it gets compounded 4 times. So if it was being compounded annually, then you would just do 6% at the end of the year. This is annually. Excuse my handwriting. Okay, quarterly, you would take the 6% and then just divide it up over the course of 4 different periods. So like instead of just making 6% interest all at once at the end of the year, 4 times throughout the year, you just take that you like gain 1.5% interest. Okay, so you're going to make slightly more interest overall. It's not going to be very different. Like these values are going to be like really close and really similar. But you can imagine like, you know, if you're making 1.5% interest and then 1.5 and then 1.5 and then 1.5, if we're just doing simple interest, like you're going to make the same amount. But if we're compounding, well, when you make 1.5% interest, well, you're going to like, and then, okay, let me say it like this. Once you make the 1.5% interest, and then the second quarter, when you make more interest, you're making interest on the interest that you made in the first quarter. And then in the third quarter, you'll be making interest on the interest that you made in the first 2 quarters, and then so on. So you'll make ever so slightly more if you're compounding quarterly. And then if you're compounding monthly, well, now we take that 6% and divide it over 12 months. What's 6 divided by 12? 6 over 12 is just a half. So the 0.5% is 0.5%. And then you just do this 12 times. Just imagine that I wrote 0.5% 12 times here. And that would be what it means to be compounding monthly. Okay. So let me shrink this, push this off to the side. Okay, so we're going to be doing this for 2 years. So we start with $2,000, and then at the end of the first month, we're going to so like each month it's kind of like simple interest where you just like do 1 plus your 6%, which I'm going to convert to a decimal, 0.06, and then we just divide that by 12. So this is going to be like our 0.5%. 0.5% is like 0.005. Right. Okay, so we do this. So we do 2,000 times, and this will end up being like 1.005, but I'm going to leave it like this just for the sake of we're building up to a formula. And then this is going to be how much money we have at the end of our first month. I'm not going to put this in my calculator. It's going to be just like slightly more than 2,000. It's not going to be too helpful or relevant to know what that number is right now, in my opinion. But then, so this is what we have at the end of our first month. This value right here, whatever it's equal to. And then we have to do this for the second month. So we then multiply by the same thing. So we just take whatever this value is and then multiply by 1 plus 0.06 over 12. And then that's how much we have at the end of the second month. And then the third month, we do this again. And then the fourth, and then the fifth, and then so on. So, and then we do this for 12 months. And after the 12th month, we have now compounded for 1 year. So if we're just doing this for 1 year, then this would be 2,000 times 1 plus 0.06 over 12 to the 12. because we're just doing it, if we're just, so I'm forgetting that we're doing 2 years for the time being. If we're just doing this for 1 year, then we would do this, we're multiplying by this 12 times. Well, what if we're doing it for 2 years? Well, if we're doing it for 2 years, then I just do 12 times 2, which is 24. If I'm doing it for 5 years, I would do 12 times 5, which is 60 months. So just however many months you're doing this for, that would be what your exponent would be. So we're doing it for 2, so let me fix that. So we would do this, and then we put this into our calculator, and our calculator tells us that this would be equal to 2254.32. So $2,254.32. Okay. All right. So there's very much a formula going on here. So we have our principal, and then we have 1 plus, we have our interest rate, we have how many times we're compounding each year. That shows up twice over here. So these are both like how many times we're compounding each year. And then this is how many years we're doing this for. So this is the compound interest formula. So A, which is the value of the account, is equal to P, the principal, times 1 plus R over N. R is your interest rate, N is the number of times per year you're compounding, and then this is raised to the power of N times T. So N is, again, number of times you're compounding, shows up twice in here, and then T is the time period. Typically, it's going to be in years. So like if you're compounding quarterly, then that would tell you that N is 4. And then if you're compounding quarterly for 7 years, then T would be 7. Compound amount, future value, etc. These all mean the same thing. That's just going to be like whatever the value of the account is after T years. So you'll just kind of every now and then see these questions phrased slightly differently, like calculate the future amount, calculate the compound amount. I think generally speaking, they all just kind of mean the same thing. So let's do an example now where we just can directly just use the formula. So a loan with principal $5,000 has a compound interest rate of 4%. It's compounded quarterly. Calculate the value of the loan after 6 years. And then as a follow-up, how much interest was made. So if you feel kind of comfortable with the material, I recommend pausing, see if you can kind of figure out what's going on, see if you can apply this formula and get the answer. And then how much interest was made, the follow-up. If you're able to do that, cool. If not, you can just kind of wait and see what happens. So I'm just going to go. I'm going to assume that you've paused by now. So according to the formula, the value of the account A is going to be equal to 5,000 times 1 plus our interest rate. So 4%, we convert that to a decimal, 0.04, divided by how many times that we're compounding in a year. Compounding quarterly would mean 4 times. And then this is to the power of 4 times 6. And we put this into our calculator, and then that would tell us this is equal to 6348.67, $6,348.67. Okay, so how much interest was made? Well, this is what the value of the account is. This is what we started with. So the interest made is just the difference, 6348.67 minus 5,000, or just 1348.67. So $1,348.67. If you wanted to know like what percentage, you could figure out like, oh, this is like what percent of 5,000. Like that's certainly a thing that you could compute as well. in this question right here, I'm just asking like how much interest was made, like what is the amount of dollars of interest that you made on this account. All right, example 4. Gian wants to invest money into a savings account that makes 3% interest, compounded semi-annually, so twice per year. If Gian wants the account to be worth $8,000 in 20 years, how much should she invest at the start? Okay, so this one is a little bit harder. So here we're not saying like what the principal is. Here we actually have to figure out what the principal is. So A equals P 1 plus R over N to the NT. It's an R. So we don't know what P is here, so we need to figure that out. So so 8,000 is going to be our A. We don't know what P is. 8,000, if that's going to be like the future value of the account. And then P is like the initial deposit, how much Gian is going to invest at the start. And then multiply that by 1 plus R, which is 3% or 0.03, divided by 2, and then this is to the 2 times 20. So 8,000 equals P times 1 plus 0.03 over 2 to the, and this will be like 40th power. Okay, well, that's fine, I guess. What can we do with this? Well, this whole thing over here, this is a constant, and so you could just divide by this. So you could just go ahead and put this into your calculator right now, and just compute what is that equal to. That would be all fine and good. Or you could just say divide both sides of the equation by this. So 8,000 divided by this whole thing is equal to P times number divided by number, so the number cancels out. And so P is going to be equal to this whole thing. And what does your calculator tell you this is equal to? Well, according to what I have written down over here, I have $4,410.10. And if you wanted to kind of check your work, what we could do is then plug this back into this equation. So we do 4,410.10 times 1 plus R is 3%, compounded semi-annually, so twice per year, and then 2 times 20 years. And I'm just going to type this into my calculator one more time just to be sure. So 4410.10 times 1 plus 0.03 over 2 to the 40. And I'm getting about $8,000 and like 0.00258 cents. So pretty close to $8,000. And there was like a little bit of rounding error when we rounded to the nearest cent. So that makes sense. So yeah, this would be our answer. All right, last thing. This is just comparing interest. So what makes more money? An account that earns 4% interest compounded semi-annually, or an account that earns 4% interest compounded monthly? So are we going to make more interest if we compound twice per year, or if we compound 12 times per year? So you could think of this intuitively. If you want to think of it intuitively, well, if you're compounding twice per year, what are you doing? Well, you're taking like 2% after 6 months and then 2% after 12 months. So you make 2% interest, and then at the end of the year, then you make 2% interest on what you had at the start, plus whatever interest you made on that. So, so that's good. What about if we're compounding monthly? So 4 divided by 12, 4 divided by 2, that's 2%. That's how we get that. 4% divided over 12 months, 4 over 12 is just like 1/3 of a percent. And then you do this 12 times. So that's 6. So we do this 12 times. And how we can think about this is, so, just in the first half of the year alone, we're going to make 1/3 of a percent, like 6 times. And like each month, you're going to be making interest on the interest that you made in the previous month. And then, the third month, you make interest on the interest that you made in the previous 2 months, and then so on. So you're continually making more like interest on the interest that you made in the previous months. Whereas like in the semi-annual case, there's like none of that, right? Like for the first 6 months, you only make the 2% interest on what you had at the start. Whereas like for the first 5 months, you're making interest on everything that you made like previous months. And then same thing after 12 months. After 12 months, like that interest just keeps compounding, keeps like getting bigger and bigger. Not by too much, because you're making interest on like 1/3 of a percent interest. And so like if these interest rates were different, like if the 4% were split up over 12 months versus like 8% split up over 2 months, then like the percentage is going to make a bigger impact here. But if you're just equating it 4% for both of them, then compounding more frequently is just going to make you more money. So let's verify this a little bit more mathematically, or more rigorously, I guess, because the previous thing was still quite mathematical, I guess. So let's just like pretend that we have like a $100 deposit, and then let's do both cases. We'll call them case A and case B. So we do 100 times 1 plus 0.04, and then we're compounding semi-annually, so divided by 2, and then to the 2 times however many years. So let's just say we do this like for 1 year. Okay. And actually, just to make the computation a little bit easier, let's just make this a $1 deposit. Okay. So this like times 1 in the front isn't going to affect our calculations at all. And then for B, we do $1 deposit times 1 plus 0.04 divided by, it's compounded monthly, so 12, and then to the 12, and then just 1 year. Okay, so I'm going to get rid of all those ones that aren't going to really matter for us, and then see, well, what does my calculator tell us that these are equal to? Well, it's telling me that the first one is 1.0404, and the second one is 1.04074. So this one, the second one, is slightly bigger. They both agree for the first like 3 places after the decimal, and then they differ at the next one. So the first one has a 4, the second one has a 7. So it looks like compounding monthly is going to make ever so slightly more interest here. It is not very significant, to be sure, but this is just like on a $1 deposit over a 1 year span. Like, of course, it's not going to make a huge difference if this is going to be happening on like a $1 million investment over like a 20-year or 40-year time frame. It's going to make much bigger difference, right? So it's important to know these things for those sorts of reasons. People like money. Right. So yeah. Oh, I'll also kind of offhanded mention. So what percent interest are we actually making at the end of the year for both of these situations? Well, we're not actually making 4% interest. If we're making 4% interest, so let's say this is like C. So we literally just make 4% interest. That would be like just 1 plus 0.04 divided by 1 to the 1. So this is literally just 1.04. So you're just whatever you had before plus the 4% interest. It's 1.04. To get how much actual interest that you want, you just take whatever this number is and then subtract 1 from it. So you get to just 0.04, which is 4% interest. For this first one, we're making 4.04% interest. And then for the second one, we're making 4.074% interest. Right. So you can actually, like, from looking at just this number right here in the p times 1 plus r over n to the n t, like if you just look at this number here, 1 plus r over n to the n, this, if you just take away 1 from it, just cut off that 1 in the beginning, or just subtract 1 from that number, that tells you what your interest rate is. Over here, of course, I'm converting this to a percentage by like, so I take away the 1, I have 0.04, and then I move the decimal right 2 places to convert to a percent. And then, so yeah, you can tell like, okay, well here I'm making a higher percent, slightly lower percent, slightly lower percent. All right, I'm kind of rambling at this point. I'm going to end the video there. Hope that was helpful, and yeah, see you in the next one.